going to discuss how the MIPS instructions are translated into machine format, or you can say into binary. So first of all, types of instructions are three: R, I, J. In R, there is 6 fields of code: RS, RT, RD, shift amount, function code. In I type, there is 4 fields of code: RS, RT, immediate. So in J type, there is 2 fields only: opcode and address. And if say each opcodes are 6 bit. Okay. Then all the registers are the 5 bit. RS is 5, RT is 5, RD is 5 bit. Because there is 32 registers in MIPS, we have 32 registers. So 32 register means we need 5 bit to save into the memory. Okay. So that's why the registers are 5 bit. And shift amount is 5 bit. And function code is 6 bit. And you will see the instruction length is 32 bit. So if you solve all the fields, you will get 32. Same as I first field is opcode, second RS, RT, and immediate field. Immediate is 16 bit. Then J type of instruction. It has only 2 fields. One is opcode, which is 6 bit. Next one is the address, which is 26 bit. So now we will see some examples that I will show you some examples, not all, some examples of R type, I type and J type. So R type, you can see some examples are here. Add R1, R2, R3, which means R1 is equal to R2 plus R3. Subtract R4, R5, R6, which means R4 is equal to R5 minus R6. And R7, R8, R9, which means R7 is equal to R8 and R9. SLL, which means logical left shift. Logical left shift. So whose opcode is SLL. Okay. R10, R11, 2, which means R10 is equal to R11 left shifted by twice. Another example is SLLV, which means logical left shift variables. Okay, variable R12, R13, R14. So R12 is equal to R13 is left shifted by R14. Means R14 contains some data. So that times will be left shifted R3. Okay, this is the example of R type. Now comes to the example of I type. So in I type, you can see ADDI R1, R2, R3. If you remember, in I type there is 2 registers only, RS and RT. So you can see ADDI R1, R2, 3, which means R1 is equal to R2 plus 3. LW R3, 20 within bracket R4, which means R3 is equal to memory of R4 plus 20. SW R5, 30, R6, which means memory of R6 plus 30 will be loaded by the value of R5. Now, last instruction is branch equal to. So, branch equal to R7, R8 level, which means if R7 double equal to R8, then it will go to level. Otherwise, it will go for the sequential education. A type is only one example, that is jump level. That means it will jump to level, go to level. See some examples of R type. Then we will go for I, then we will go for the J. So for the R type, as I can say the diagram, the 6 field opcode RS, RT, RT, shift amount, function code. Now let's say the opcode field for the ALU operations is always 0. Okay, so for R type, the opcode is always 0, and function code will determine that what it will do. Okay, like the operation it will determine. Now so here already written the bit size for each field. Now we have take some assumption. Let's say the function code for the ADD is 32, subtract is 34, and is 36. SLL is 1 and SLLV is 4. Now take the first example, add R1, R2, R3. Okay, so when we translate this assembly language into the machine format, so how it will look like? So opcode field is always 0 because I have said in the R type opcode is always 0. RS is the first source operand, that is 2. RT is the second source operand, that is 3. RD is the destination operand, that is 1. Okay, that is R1. Okay, so you can see 1. Then shift amount is 0 and function code is what it is. We have taken the assumption, that is 32. Now, but regarding the shift amount, this field is filled out when we will get the instruction like logical left shift, logical right shift, or arithmetic right shift. So for such cases, this shift amount field will be has some value. Okay, but for the add, subtract, divide, multiplies, and or exhaust, for such cases shift amount remains 0. Okay, now so now just translate this decimal value into binary. So already I have written here what is the translation of this decimal into binary, and the size is already I have mentioned here. Okay, like opcode is 6 bits, so it means 60. RS is 2, so 2 means 10. As RS is 5 bit, remain 3 bit will be 0. Okay, so like that it will be translate into the binary. Now comes to the another example, subtract R4, R5, R6. Okay, so when you translate this into the binary format, so opcode will be 0. Okay, so RS will be the first operand, that is 5. RT will be 6. RT will be 4, and shift amount remains 0. And for the subtract, we have taken the assumption 34. Okay, so just translate this into the binary. What you will get? So this much value you will get. Just translation, the from decimal to binary, and the size of each field is mentioned in the above. Now, third example, SLL R10 R12 2. Okay. Now, so when we translate, opcode is 0. Now, so it is a little bit tricky. See, as already there is 3 registers, but here we have only 2 registers, and it is a R type instruction, not I type. Okay. Okay. So now question is which one is RS and which one is the RT. Okay. So RS is remain silent, that is 0. RT is your source operand, that is your 11. RD is your destination, that is 10. Okay. So remember RS will be 0. Okay. This part is 0 for this SLL. For SLL or SLR, so for such cases RS will be 0. So 11, 10, and how much left shift? Twice. So 2. Okay, see, shift amount is 2 here, not 0. And function code is, I have taken the assumption SLL function code is 1. It can be anything, it will be given. Okay, so just take your translation. So 0 will be translated to 60. This. So you can see the translation of decimal into binary. Now comes to the last example of R type. Is LLV R12, R13, R14. Now when you translate, you will see this is a logical left shift, but constant is not given. Okay, so this how much you will see it will given in the register. So that's why it is the name is variable. Okay, so that's why you will see the shift amount is 0 because here it is not a constant. Okay, so now question is which is the RS, which is the RS, RT, RD. So RT is always 12. Okay, RD is what? 12 destination. So what is the first source and second source? First source is now which is the RS. So RS is the 14, RT is the 13, 12 will be the destination. Okay, then just translate this into the what binary. Okay, that's it regarding your R type. So in I type, opcode, RS, RT, immediate. So in opcode is 6 bit, 5 bit, 5 bit, 16 bit. So let's say some examples, not all, some examples. ADDI R1, R2, 3, which means R1 will be added by R2 plus 3. So now let's assume the opcode for the ADDI is 10. So we will translate into machine format. The opcode is 10, which is the RS and RT. RS is the source to, while the RT, T is the target. Okay, so 2, 1, and your immediate is 3, and it is a sign extension. Sign extension. Okay. Now, when it will translate into binary, it will be 0, 0, 1, 0, 1, 0. 2 will be translated to this, 1 into translated to this, and 3 will be translated to here. So as it is 16 bit, so you have to mention this many zeros. So I have put dotted here, but always remember this will be a 16 bit. Okay, that means 2 ones are there, that means these are the 14 zeros. Okay, now comes to the second type of example. In I type, load. How it look like? Load RT comma immediate within bracket RS. Okay, so always remember the base register is always RS. Okay, so now for the example, load comma 20 within bracket R4. So when you translate it to the machine, we have the assumption is 11, opcode of LW is 11. So 11, RS is your 4, RT is 3, and your immediate field will be 20. So each field will translate into the binary. So 11 translation, 4 translation into binary, 3 translation into binary, and 20 is translated to here. Okay. Same for the store operation. Store RT comma immediate within bracket RS into the binary. So opcode, let's say we have just an opcode is 12, and 6 is the RS, and 5 is the RT, and 30 is the immediate field. Okay, so then translation into the binary, already you know. Okay, now comes to the last example of I type, that is branch equal to R7, R8, 30. So assumption is what? Branch equal to opcode is 30. So 30, RS is your 7, R8, RT is your 8, and immediate field is your what? The label value, it is 30. So everything will be translated into the binary. Okay, so this is regarding your I type. Now comes to the J type. So in J type is what? Only two field, opcode and address. So let's say example, jump 64. Assumption is what? Opcode of jump is 15. So when you translate into this, 15 is the opcode and address value will be 64. Okay, so then translate into the binary. Okay, so this is regarding your what? The translation of assembly level language to machine format, that is your 10, that is means binary format.